Okay, I want to talk about two claims that are made by flat earthers a lot. Um, they're both fairly simple, both fairly easy to wrap your head around and to understand. Um, but it helps with a visual representation. So I thought I'd make one. So these are one, that the Earth isn't a perfect sphere; it's an oblate spheroid, and two, that you can't see the curvature of the horizon. So, first of all, oblate spheroid. Okay, so oblate spheroid, the diameter one way is slightly different from the diameter the other way. These terms kind of get bandied around a lot by flat earthers, that the Earth is an oblong or a or egg-shaped or pear-shaped, um, which are kind of true. The pear-shaped bit anyway, because there is a bulge due to the rotation of the Earth and the Earth's composition. But that bulge is very, very slight. So a lot of flat earthers say, well, shouldn't you be able to see that? Every picture I've seen of the Earth looks like a perfect sphere, therefore it must be fake, because we all know, or NASA says, it's not a perfect sphere. So just to show you how that actually looks, this is within the program Adobe Illustrator, which is a vector-based graphic program. This is a scale representation of the Earth, looking side on. The North Pole at the top, the equator running across the middle. The scale I'm using for this purpose is 1 millimeter to 10 miles. So you'll see up here we have the width and the height of this circle that I've drawn, and this is currently at the correct scale to what we know is the diameter of the Earth from around the equator and from pole to pole. So the 1 millimeter being 10 miles, you can see the width there is 792.6 millimeters, which represents 7,926 miles, and the height 790 millimeters, representing 7,900 miles. The difference between the two is only 26 miles. So across the nearly 8,000 mile diameter of the Earth, that 26 miles is hardly anything, almost imperceptible, unless you really measure it precisely. As you can see, that looks like a perfect sphere, but we can see from the dimensions that it really isn't. If I just undo the scaling, take it back to what I had it set to before, you'll see that, excuse me, that wasn't quite right. Let me take this down like that. There we go. That now is identical, 790 by 790. That is a perfect sphere, or a perfect circle. As you can see, it looks exactly the same, and if we take that back to where it was before, there's the dimensions, and you can see that looks pretty much exactly the same. Unless you overlaid a very, very high resolution picture of the Earth, as you can get from some satellite images, over a perfect circle, or measured it pixel by pixel, you're really not going to see that difference. So that's one explanation for the sphere-like appearance of the Earth. Next, we'll look at the claim of curvature. And why don't we see curvature? Now, it's pretty obvious to most of us that, especially if you're stood on the ground, you're so small and the Earth is so big that you're not going to see curvature on the horizon. But I still do see flat earthers make this claim. Recently, there was a video by the guy on the Your Curveless Earth channel. I don't know your name, I'm afraid, but he went out to interview people on the street and asked a kind of leading question, which was, how many horizontal lines does it take to make a ball? People didn't really have an answer to that, obviously. Um, and then he said, well, what do you see when you look at the horizon? You see it's flat, right? So what does that tell you? That tells you we must be on a flat Earth, because you can't have a flat line or a horizontal line making a ball. So I think a lot of flat earthers would even kind of laugh at that, but let's just have a look anyway and see just how ridiculous that claim is that you should see curvature when you look at the horizon from a standing position on the surface of the Earth, which is preposterous. So again, our scale model of the Earth, if we look at a horizon calculator at a viewer height of 6 feet, average kind of tall guy, the horizon is 3 miles away. So going back here, obviously if you were on a ship in the middle of the ocean, you'd be able to see 3 miles in one direction and 3 miles in the other. And so that would be a total of 6 miles. So if I zoom in, you'll see a tiny little box there. When I click on that, you'll see that the dimensions of that box are 0.6 millimeters wide by the same high. So again, the scale is 1 millimeter to 10 miles. So 0.6 millimeters represents 6 miles. So this, from here to here, is your observable horizon. This is what you could see. If you were in the middle here on the surface of the Earth, you'd see this far this way and this far this way. And this is about what you would see as the horizon 180 degrees left to right. So let's zoom in on that. Get nice and big on the screen. And then take this straight bottom line of the box and bring that up. Oops, excuse me. Try that again. And you'll see that it sits absolutely perfectly on there. It's flat, it's level, it's about as flat as you can get, certainly to the naked eye. It's only when you then zoom out that you realize that that flat plane, or seemingly flat plane, was actually just a very, very small part of a very, very big round ball.